In the previous lecture, we were discussing n-parameter family of solutions, and we also have discussed initial value problems, nth order initial value problem, first order, second order, and so on. So today we are going to discuss the techniques for solving first order differential equations. First of all, we are going to discuss how to solve first order ODEs. And first order ODEs, the first thing, and the second thing is techniques for solving. Techniques for solving or techniques of solution. How to solve first order ODEs. So these two things we are going to discuss. The first thing which we should know is what is the general type of first order differential equation. I already told you that the general form of the first order differential equation is of this form: f of x y dash is equal to 0. I told you this thing in the previous lecture, where x is the independent variable, y is a function of x, and y dash is the derivative of y with respect to x. Okay. And the interval for this differential equation could be an interval in real line, or you can say also x belongs to R. It could be anything. So this is the general form of the first order differential equation. We have another general form of the first order differential equation, which is this thing. This is the most general, and you can say a particular, but another general form of the first order differential equation is this: dy by dx is equal to, you can say g of xy or small f of xy. Okay, in this form, we write the derivative of that differential equation on the left hand side, and the rest of the functions, function of x and y, on the right hand side. So this is another general form of the first order differential equation. Another, we can write maybe, you can say that another general form is m of xy dx plus n of xy dy is equal to 0. This is another general form of the first order differential equation. We can write this differential equation in this form, or even in that form. How can we write? If we take this thing on the right hand side, we can have n of xy dy is equal to negative m of xy dx. Now you divide this thing on the other side, and from there we can write dy by dx is equal to negative m of xy divided by n of xy. So this whole thing is a function of, it's a fractional function, or you can say rational function. M of xy is a function of xy. This denominator is again function of xy. So as a whole, it is a function of xy. So we can write it f of xy in general, where f of xy is so this differential equation can now be written in this form. So this is again a special case of this form. So we can write first order differential equation in this form, in this form, in this form. And another general form of the first order differential equation is linear first order differential equation. We have written this form in the previous lecture. Linear form is what? Linear first order ODE. I told you this in the previous lecture. It is of the form a1 of x dy by dx plus a naught of x y is equal to some function g of x. So this is again a first order differential equation. We can further simplify this thing, and we can make this thing in that form, which is the general form of that first order differential equation. We divide the whole thing on both sides by a1 of x. Okay, where if we assume that a1 of x is not equal to 0, Then we can divide and we can have dy by dx plus a naught of x divided by a1 of x into y is equal to g of x divided by a1 of x. Now, if we assume that this thing is p of x and this right hand side is q of x, okay, then this differential equation can be written in this form: dy by dx plus p of x y is equal to q of x, okay, along with a1 of x is not equal to 0. So this is a general form of the first order linear differential equation. Now this is another form which is called standard form of first order linear ODE. So you have to remember all types or all forms of the first order differential equations. Okay, while solving these differential equations, these forms are important. We have to look at the forms as well. If you have any question, you can ask me. Any question? No? Okay, then let's move forward. Another form of the first. जी. Yes. जी बोले, मुझे आवाज आपकी कट के आ रही है, बोले।
सर मैं कह रहा था आप प्लीज पिछला वाला बोर्ड एक सेकंड खोल सकते हैं?
ये ले। I have no problem.
सर इसमें P और Q आर्बिट्री हमने वेरिएबल्स दिए हुए ना, या इनका कोई आगे जाके मतलब बनेगा?
Yes, we'll use these functions as well while solving linear first order differential equation. Okay, this is the general first order linear differential equation. We have to convert this differential equation into the standard form first, and then we shall apply a technique for solving linear first order differential equation. Okay, we'll use these things. That's why I told you all the possible forms of the first order differential equation. Okay, these are all possible forms of the first order differential equation. For different techniques, we use different forms of the differential equation. Okay.
Okay, sir. Thank you.
Okay, now we are going to discuss our first technique for solving first order differential equation. Okay, which is the method of separation of variables or separable differential equations. So it is separable ODEs. Separable first order ODEs, you can say that. First order ODEs. Now, this is the first technique we are going to discuss how to solve those differential equations, how to solve these first order differential equations. This is the first technique. In this technique, we have to look at the differential equation. The form of the differential equation should be like this. The form of separable, general separable, you can say. General separable ODE is what? It should be dy by dx is equal to some function of h of x and some function of y, g of y. The general form of the separable ODE is this thing, or what you have to look at the differential equation, the variables should be separable. We should be able to separate the variables. Okay. Now, if the form of the differential equation is this thing, we can divide this h of x on the other side. So, sorry, g of y on the other side. We can write it as g of y times dy is equal to h of x times dx. We can separate the variables here. Now, you can see that on the left-hand side, we have only the variable y, and on the right-hand side, we have only the variable x, nothing else. There is no mixing of variables on either side. So the variables have been separated completely. So this differential equation or a first order differential equation in which we can separate the variables completely is basically a separable ODE, first order. Now, after separating the variables, what we have to do, we have to integrate both sides. Okay. Now, अगर लेफ्ट हैंड साइड पे वेरिएबल y है तो ऑब्वियसली वी हैव टू इंटीग्रेट विद रिस्पेक्ट टू y. राइट हैंड साइड पे अगर वेरिएबल x है तो वी हैव टू इंटीग्रेट the right hand side with respect to x. So after applying the integration on both sides, what do we obtain? H of x dx. So the integration have been applied now, plus some integration constant we have to add here. Now, till here, this was the technique, how to solve that first order differential equation. Now, after this thing, your techniques of integrations come into play. You have to be very good in integration techniques. Now, you have to integrate this side and this side. This side will be integrated with respect to y, and this side will be integrated with respect to x. After integration, you get the solution. Whether it could be implicit solution or explicit solution. Okay. It depends on the expressions after after doing these integrations. I hope you get it. If you have any question, you can ask me. Another form of the separable differential equation could be, this is the general form, but I'm going to tell you another form. Maybe it could be a function h1 of x g1 of y times dx plus h2 of x g2 of y dy equal to 0. So this could be another form of the separable differential equation. You have to look at closely here the variables. You can see here that the coefficient of dx is a function of y and function of x. They are separate functions. They are not mixed into each other. They are separate functions. So if they are separate functions, here also it's a function of x and it's a function of y, then we can, after simplifying, we can obtain the similar kind of form here of the general separable differential equation. So this could be another form of the separable differential equation. You have to separate the variables. How can we separate from here? We can take this side on the other side, this term. We can take this term on the other side, and then we can separate the variables by dividing the respective terms of h1, g1, h2, or g2. I hope you can do that. Do this. You can separate the variables from here as well. So let me help you if you think, how can we do it? This one is what? h2 of x, g2 of y, dy is equal to negative h1 of x, g1 of y times dx. Now, you can take this x on the other side and y on the left-hand side. So we can write g2 of y divided by g1 of y times dy is equal to negative h1 of x divided by h2 of x dx. Now, you can see the variables have been separated. On this left-hand side, we have only y variable, and on the right-hand side, we have only x variable. Now you can integrate on both sides with respect to x and respect to y, respectively, and adding a constant. After doing this, you have to integrate these two expressions in order to get the solution, which doesn't involve any derivative. So what is the purpose of while solving these differential equations? We have to eliminate that derivative and we have to find the value of y, which is the dependent variable. This was basically the purpose of solving these differential equations. We have to find their solutions. We have discussed in the previous lecture what are the solutions of the differential equation. If you have any question, you can ask me. If there is no question, let's do a couple of examples and then we shall move towards the next technique. Let's do some examples. This one, maybe. Example 1. Consider this differential equation and solve it. dy by dx is equal to y squared x e raised power 3x plus 4y. Now, by looking at the differential equation and its right-hand side function, can you guess here that whether we can separate the variables here? Can we separate the variables? Anyone?
Yes, sir.
Yes, sir.
How can we do? We can write
को
this thing as e squared into e raised power 4y. This is one function, and the other function is x e raised power 3x, because we can break this e power 3x plus 4y into this thing and 3. So now we have two functions. So this one, you can say this is h of x, and this is your g of y. So these are two separate functions. On the left-hand side, we have dy by dx. So what we do here, we have to divide this thing. Sorry, मैंने गलत लिख दिया, उल्टा लिख दिया. So h of y and g of x. So what do we have to do? We have to divide this function on the left-hand side, and we have to take this dx on the right-hand side. So in order to separate the variables, so it is over y squared e raised power 4y dy. And on the right-hand side, what do we have? X e raised power 3x. So the variables have been separated now. And so we have to write here dx as well. Now what we have to do, we have to integrate both sides. Integrate both sides. So what do we get here? Integral of 1 over y squared into e raised power minus 4y. dy is equal to what? X e raised power 3x integral respect to dx plus some constant of integration c. Now you should know all the integration techniques in order to integrate these two functions to get the answer, or means of solution of this differential equation. I hope you can do this integration. You have to apply here integration by parts, here as well integration by parts, and after integrating it, you can get the solution. Can you do it? Tell me.
We will have to revise. Last में किया था भूल है.
हाँ, आपकी इंटीग्रेशन टेक्निक्स आप लोगों को भूली होंगी. You have to revise those integration techniques to get the solution here. I hope you can do it. Otherwise, I'll advise TA of this course to give you some brief, you can say, brief review of the integration techniques in the tutorial of this week. ठीक है? Tutorial में TA को I'll ask him to give you brief review of the integration techniques. So try to attend that tutorial. I'll definitely advise him to do so. Next example could be example 2 is solve the following differential equation. Okay. Masalan 1 plus x dy minus y dx is equal to 0. Now you can see here that we can separate the variables. Here we have a function of x into y, here we have a function of y, and dx. So we can separate the variables. So we can write here 1 plus x dy is equal to y dx, and then y would definitely come here, dy, and then 1 over 1 plus x dx. So you have now separated the variables. What is left to do now? We have to integrate both sides. 1 over y dy is equal to 1 over 1 plus x dx plus a constant c. So it's simple integration. 1 over y की integration क्या होगी? Natural log of y plus इसकी integration क्या होगी? Natural log of 1 plus x. ठीक है? Sorry, not plus. यहाँ पे equal. You have equal here plus a c, a constant c. It's a simple technique of integration in order to simplify your solution. Sometimes if all the other times are in log, we can also write this c as a log of some constant, natural log of maybe c1 or c0. Okay, so this is the common practice while simplifying these functions or solutions. Now we can use these log properties in order to simplify the solution. So we can further write it, natural log of y is equal to natural log of what? C times 1, C0 times plus 1 plus x. Now we can eliminate log from both sides, and we can get y is equal to what? C0 times 1 plus x. So this is your solution of the given differential equation, where you have to define the interval of x so that these two, this y and this term should be positive in order to get the valid solution of that differential equation. Any question? So this is your explicit solution. Okay? Explicit solution. In the previous case, we would definitely get the implicit solution after integrating. So this is all about the separable differential equation. If you have any further question, you can ask me. And for more details and more examples, you can see my lecture of separable ODEs in the MATH120 course, which is already uploaded on YouTube. I'll also advise TA to give you some further examples in the tutorials for your practice. If you have any question, you can ask me. No question? Okay, then let's start the other kind of the next technique for solving first order differential. This is the first technique, separable, separation of variables, or you can say that separable ODE, first order ODE. The next method is, second method is method of integrating factor for solving first order linear, आप इसको यूं भी कह सकते हैं, first order linear ODEs. Okay. The first technique, what do we call it? Separable differential equation. How to solve them? We have to separate the variables x and y on either side of the equation, and then solve that equation by integrating. Now, what is the first order linear ODEs? Whatever the form of the differential equation we have discussed, I gave you different forms of the first order differential equation. First, we have to convert that differential equation into the standard form. What I told you, what is the standard form of the first order differential equation is no, not here. Here, yes. whatever the form of the first order differential equation, in order to apply this technique of first order linear ODEs, you have to convert that form into this standard form. Okay, this one. I hope you get it. Whatever the form of the first order differential equation is given, either it could be given in this form, or the first order differential equation can be given in that form, maybe this form or any other form. First, you have to convert that differential equation into the standard first order linear differential equation, this one. If you can't get this kind of differential equation, we cannot apply that technique, first order linear differential. That equation won't be first order linear ODE, and we cannot apply that technique. And how to, so if we are given a differential equation of general first of this form, dy by dx plus a naught of x y. No, I haven't changed the view of the camera. Sorry for that. I hope you can see it now properly. If we are given this kind of differential equation, a1 of x dy by dx plus a naught of x equal to y is equal to some function, maybe f of x. Okay. So you can see here that y is linear. The power of y is 1 here, power of y is 1 here. The coefficients only involve function of x. A1 of x is only the function of x, a naught of x is only the function of x, and the right hand side is also a function of x only. It cannot involve y. So if you have this kind of differential equation given, then we can apply this technique, or any other differential equation first order, whom we can convert into the standard form. First, we have to write any given differential equation into standard first order linear form. Okay. This is your standard first order linear form, which is dy by dx. And I already told you how to obtain this. You have to divide this a1 throughout on the both sides, and you can get this kind of differential equation dy by dx plus p of x into y is equal to some q of x. Okay, where p of x is what? It is that thing, a naught of x. Only in this case, it could be different, but in this case, the p of x will be this, where a1 of x should not be 0 for any, for all x belongs to whatever the domain of this differential equation is. Whatever the domain of this differential equation is, means whatever the possible values of x we have. So first, convert any first order differential equation into this standard form, and then proceed further. What we do now, we have to eliminate the first order derivative from this equation. How can we do that? We have to integrate, but we cannot integrate here directly on both sides. That won't help us to eliminate the derivative, because we don't have integration with respect to either x or y. It's a mixed kind of function, because y is dependent on x here. This p of x into y cannot be integrated only with respect to x or y, because it involves both variables. So in order to eliminate this derivative from here, what we do here in this technique, in this particular technique, we try to make here, we try to combine these two terms. So in order to do that, what we do, we introduce an integrating factor. Integrating factor is a factor which we will multiply on both sides of this differential equation in order to combine these two terms. Now, what is that integrating factor? It is e raised power integral p of x dx. And how do we know that this term, if we multiply this term on the left, on both sides of this equation, let's try it. I'm considering this term, and this term I'm going to multiply on both sides of this differential equation. For example, I call it equation 1. So if we multiply this thing e raised power integral p of x dx dy by dx plus e integral of p of x dx into p of x into y is equal to, you can say, q of x e raised power integral p of x dx. I multiplied this given differential equation with this factor on both sides. Now, if you look at this factor, which is on the left-hand side of that differential equation, what is this? It is, in fact, the product rule of derivative of what? We can write this left-hand side as d by dx of y integral of p of x dx, this thing. Can we combine this left-hand side, the two terms of this left-hand side into one, into this one term, which is basically derivative of the product of these two functions? Can we do it? Now let's try. First, you take the derivative of y. The second function would remain same. I hope you know how to apply the derivative on the product of two functions. Product rule, derivative product rule. I hope you remember it. So what we are going to do, we are going to apply this derivative on the first function. The second function would remain same. What will this thing give us? It will be dy by dx into e raised power this thing, which is the first term. E raised power this thing into dy by dx. Okay. Now what we do plus, now y would remain as it is. We apply the derivative on the second function. Now, if we apply the derivative on this function, what will be the derivative of this thing? Anyone can tell me what will be the derivative of? चलें यहाँ पे हम इसको सॉल्व करते हैं. So what was the term? dy by dx times y times the integral of this function. If we apply the derivative on y, so what do we get? dy by dx, the first function, derivative of first function. The second function would remain same, e raised power integral p of x dx. Now plus, first function as it, we apply the derivative on the second function. It means derivative of what? Derivative of e raised power integral p of x dx. What is the derivative of e power integral p of x dx? Can anyone tell me? Speak up. Who is there? Ashish J, you tell me.
I'm sorry, sir, I didn't get your question. Can you please repeat?
Huh?
Sir, p of x नीचे आ जाएगा.
Who is this?
Sir, Ubaid.
Ubaid. Okay. P of x नीचे कैसे आ जाएगा अभी?
Sir, integral of sir derivative of integral of p of x dx को cancel हो जाएगा ना, और वो multiply हो जाएगा नीचे.
Again, what is? Let me. You people tell me what is the derivative of e raised power function of x, not integral. What is the derivative of e raised power f of x? What is the derivative of this thing? Can you tell me?
So derivative of f of x into e to the.
Its derivative is what? E to the power f of x, same as it is into
Derivative of f of x.
f dash of x, means derivative of this exponent.
Yeah.
This is the power thing, whatever we have here. Now, if we want to find the derivative of this thing, what will be the derivative of that thing? It will be y as it, and the derivative of this thing, it will remain same, e to the power integral p of x dx times the derivative of this thing. So the derivative of this thing, we have integral here. When we take the derivative integral will be cancelled. What do we get here? Only the p of x.
Plus
You got
c.
it? Okay? You got it?
I got.
Okay. Now, what do we obtain here? This is exactly the left hand side here, this is the exactly equal to the left hand side we had here. It means the left hand side of this differential equation, after multiplying this factor, the left hand side will become what? This product rule, the derivative of product of y into e raised power integral p of x dx. And the right hand side would remain q of x e raised power integral p of x dx. Okay. Now you can see that we have combined these two terms on the left hand side of this differential equation. Okay, we have combined these two terms. हमने इसको combine करके एक derivative of this whole thing में ले आए हैं. ठीक है? The derivative of this whole thing. Now we can integrate both sides. If we integrate on both sides, integral here will be cancelled with the derivative. We'll get only this thing. And we apply an integration here. Here we have only the function of x. We can integrate it easily by using integration techniques. So this was the term we obtained on the left hand side, and on the right hand side, what we had, it was q of x times e raised power integral p of x dx. Okay, after obtaining this, what we do, we apply integral on both sides. We integrate it with respect to x. Okay, let me write it below so that you can remember it properly. So now we integrating both sides. Okay, integrating both sides with respect to x. Okay, because here we have derivative with respect to x, and here we have only the variable x. So integration on both sides will be with respect to x. So what we are going to do here, integral of this d by dx of y e raised power integral p of x dx, this thing with respect to x integral, and the right hand side is integral of integral of this whole thing, which is q of x e raised power integral of p of x dx. This whole thing is integral with respect to x. Now, from this side, this derivative and integral will be cancelled, okay, along with this thing as well. So derivative and integral will be cancelled out, and we'll get this term as it is. So what do we get here? Y e into e raised power integral p of x dx is equal to integral of this whole thing. Okay, we get the same thing here, respect to dx. Now, we have eliminated the derivative of y with respect to x. So this is your solution. After some simplification, you can divide this term on the other side here. You can get an explicit solution, which is y in terms of x only. After performing the integrations here, you will get an explicit solution. I hope you get it. So the further, what we can do, we can divide this function on the other side in order to get y is equal to, जब आप इसको उधर डिवाइड करेंगे तो ये रेसिप्रोकल में जाएगा, ऊपर जाएगा तो यहाँ पे नेगेटिव आ जाएगा, क्योंकि आपके पास अगर ये डिनोमिनेटर में है, पहले आप इसको डिवाइड करेंगे, e raised power integral p of x dx आएगा, साथ में integral of this thing with respect to x, and if this is in denominator, we can take it in the numerator by writing here e raised power negative p of x dx. I hope you know why I wrote here this negative sign, because 1 over a power maybe x is equal to what? A raised power negative x. Denominator को ऊपर लेके जाएंगे तो negative power आ जाएगी. I hope you know this properly. So this is your explicit solution after performing these integrations. You get y in terms of x as a solution of the given differential equation. This is the general kind of procedure of solving first order linear differential equations. If you have any question, you can ask me. Otherwise, let's discuss a couple of examples of this technique as well. Yes.
तो ये पूरा प्रोसीजर करना जरूरी है या फिर हम डायरेक्टली बस y इक्वल्स टू e की पावर माइनस bx dx लगा दें?
If you can remember this, you can apply it directly as well. But at least you have to find the integrating factor. Okay, first you have to identify whether the given differential equation is first order linear differential equation or it can be converted into first order linear differential equation. First, you have to write the standard form of the linear differential equation. Then you have to find its integrating factor. You have to find its integrating factor. Then you can use the direct formula as well. Okay, but you have to mention it is the first order linear differential equations. I hope you get it. If you have any question, you can ask me. Any further questions? Otherwise, let's discuss a couple of examples of this technique as well. Oh, it's very, very simple. Maybe this one. Solve the following differential equation. Solve the following ODE. Okay, the ODE is x dy by dx minus 4y is equal to x squared e raised to power x. Okay, so this one we are going to solve here. By looking at this differential equation, I can judge that this is the linear first order ODE. So we have to make a couple of modifications in order to get the standard form of the linear first order ODE. What are the modifications? We divide this x on the both sides, but x should not be 0. Okay. Or I can give you here the domain of this interval. For example, I can say that x varies between x is greater than 0, less than or equal to maybe 1. So this is the domain of this differential equation. Means the variable x in this differential equation can only vary between 0 and 1. So if x is greater than equal to, greater than 0, then we can divide this whole equation by x. Okay, means x cannot be 0 here. So you have to look at the domain of the differential equation as well before dividing with this coefficient function throughout in this equation. So what we do, we are going to convert it into the standard form first. The standard form will give us the function p of x, which we are going to use to find the integrating factor. So dy by dx is equal to, minus 4 by x, y is equal to x e raised to power x. Because we have x squared here, when we divide this thing with x, so x cancel ho jayega, we get x times e raised to power x. Now this is your standard form of the first order linear differential equation. Next we are going to find the integrating factor. Integrating factor is what? E raised to power integral p of x dx. Okay, you have to remember this. Now what is the p of x here? You have to identify the p of x here first. So this is your p of x. And what is this? This is your q of x. So we just insert the value of p of x here, which is negative 4 by x. So we can write negative 4 by x here dx, and then we have to integrate it. We can take negative 4 outside, 1 over x dx. Okay, and then what is the derivative of 1 over x? It is negative. Derivative of 1 over x is natural log of x, so log of x. Now we can further simplify it by using the properties of log. How can I solve it further? I can write it e raised to power natural log of x raised to power negative 4. क्योंकि negative 4 इसकी power में जा सकता है ना. It's the property of log. Now, e and log can be cancelled out here by using the exponential and log property. So this can be written as e raised power -4, which is 1 over x power 4. Okay. So this is your integrating factor. Okay. Now, if you multiply that given differential equation with this factor on both sides, the left-hand side would be combined into a single term, which will contain the derivative of the product of two functions. The one function would be y, and the other function would be the integrating factor. So this can further be written. Can I erase this thing? I hope you understood it. So now, what after finding that integrating factor, we can write this left-hand side, this thing into a single term d by dx of y into integrating factor, which is 1 over 4. And the right-hand side would become 1 over 4 times the integrating, this function times the integrating factor. Okay, this function x e raised power x into 1 over x power 4. This is what we had done in that procedure while solving the general first order ODE. So now we have this differential equation, or this equation, and this equation can be simplified further before applying the integration. So यहाँ पे x और यहाँ पे 4 cancel हो जाएगा, we get 3 here, and after integrating on both sides with respect to x, integrating with respect to x, both sides, what do we get here? D by integral of d by dx of y times 1 over x power 4 dx is equal to integral of 1 over x power 3, which is x power -3 e raised power x. So -3, not 4. -3 e raised power x. So dx plus a constant of integration. Now, you can cancel out this derivative with the integral, and what do you get here? Y times 1 by x power 4 is equal to the integral of this thing. Okay? The integral of this thing would be what? थोड़ा सा नीचे लिख लें इसको, mix up no terms. So it would be y times 1 over x power 4 and the integral of e raised power -x cube x power -3 into e raised power x dx. Okay. Now you have to apply integration by parts here. You choose this function as the integral function. No, this function as the integral function, and this function as a derivative function. And after applying integration by parts a couple of times, this term will be vanished, and we will be left only with this term after applying a couple of maybe 2 or 3 times integration by parts. You can integrate this factor, and you can whatever the expression you get after performing this integration by parts, you multiply this x power 4 on the right hand side, you get y is equal to x power 4 times the solution of this integral plus some constant c. I hope you can do this by using your techniques of integrations. I hope you know it.
सर x power 4 c के साथ में मल्टीप्लाई होगा ना?
X power 4
जो है वो
हाँ yes x power 4 c के साथ भी multiply होगा. Yes, you are right. So you have to get the answer of integration here plus c, and x4 will be multiplied with the c as well, because we have c already here as well. Thank you.
So in the integrating factor, when we were proving that we didn't add plus c there, why didn't we add plus c there?
Bon. That would not change anything but to complicate our simplifications. Okay. Our purpose is not, basically we are not getting solution after that integration. Okay. The constant in the first order differential equation should only appear once, because if we have a first order differential equation, I told you in the previous lecture that we should have a one parameter family of solutions. ठीक है. अब अगर आप इंटीग्रेटिंग फैक्टर में वहां पे कांस्टेंट ऐड करेंगे तो आपकी जो लेफ्ट हैंड साइड है वो कंबाइन नहीं कर सकते आप फिर. ठीक है. तो प्रोडक्ट रूल नहीं बनेगा. So the integration constant could be 0 as well. In that case, we are assuming that the integration constant is 0. Because if we add a constant there, we cannot convert the left-hand side into a product rule. And that will complicate our simplifications. We need only one constant of integration, which we use or which we write here while integrating that equation. I hope you get it. It's just a technique of eliminating the derivative.
Thank you.
Okay. Any other questions? So this is all about the linear first order ODEs. This is how we can solve them. If you have any question, you can ask me. Let's do another example, maybe, just to clarify further your concepts. चलें हम एक सिंपल सी एग्जांपल करते हैं जिसमें इंटीग्रेशन भी हो जाए और I can show you some initial value problem. चलें अब हम now we are going to solve an initial value problem in which we will find the value of C as well. Now the initial value problem of first order. How can we write it? I told you in the previous lecture how to write initial value problems, and I gave you an example of the Newton's cooling law as well. How can we write the initial conditions to the differential equation, along with the differential equation? The initial value problem is generally what dy by dx is equal to f of xy, along with equation, along with some initial condition. We call it initial condition IC. In short, initial condition is always on the initial value of that variable and equal to some value of the variable y. You can say it maybe is alpha, is some constant. Okay. So how to solve this initial value problem? You can apply separation of variable technique as well on solving this initial value problem, as well as linear first order differential equation. You can apply that technique. Solving initial value problem doesn't change anything. You can apply any technique. For example, if we have an initial value problem, the difference is that, for example, solve the following initial value problem. Solve the initial value problem. Initial value problem. First order initial value problem. First order initial value problem. And it is what? It is given as dy by dx minus 3y equal to 0 with, in this case, we are given an initial condition as well. Y of 0 is equal to, for example, 2. And this is the initial condition. I told you in the previous lecture what are the initial conditions and how can we write them. So our purpose is to solve this differential equation. Now, by looking at the differential equation, I can see that this differential equation is first order linear differential equation. What is IC on the left? IC is initial condition. Initial condition. It's a condition. See my previous lecture. What is the initial condition and how can we write them? So this is your initial value problem. It contains only the first order differential equation. By looking at the first order differential equation, we have to decide ourselves what technique we can use in order to solve it. Okay. There are questions in the chat window. Let me see them. Initial condition. Okay, that's fine. Now, by looking at the differential equation, this is me who is going to decide what technique I am going to apply in order to solve that differential equation. So I can solve this differential equation by using the separation of variables, separable differential equation as well, because we can separate the variables. As well as I can solve this differential equation by using that technique of solving linear first order differential equation by finding its integrating factor. The solution by using both techniques will get the same solution. The solution won't change. For example, let me solve this using by finding integrating factor. So integrating factor is what? E raised power integral p of x dx. So this differential equation is already in the standard form, so I don't need to convert it into standard form. So what is p of x? It is -3. So e raised power -3 integral dx. So its integral is e raised power -3x. Okay. So this is our integrating factor. Now, this left-hand side can be converted into, or what we do, we multiply both sides of this equation by integrating factor. The left-hand side will become the product rule of y and this integrating factor, and the right-hand side here is 0, so it will become 0. So what do we get here after multiplying this equation with integrating factor? We get dy by dx of y times the integrating factor, which is e to the power -3x is equal to 0. Okay. Now, what we have to do, we have to integrate on both sides. The right hand side is 0. So it will be what? Anyone? So now integrating d by dx of y e raised power -3x respect to x is equal to integral of 0 dx. Now, what is the integral of 0? Anyone can tell me? Kyo Mariam? What is the integral of 0?
A constant.
Yes, thank you. So integral and derivative will be cancelled here. We get e raised power y e raised power -3x is equal to a constant c, which is the constant of integration. अच्छा, इसका इंटीग्रल तो कांस्टेंट आएगा, हमने c कह दिया इसको, प्लस एक और कांस्टेंट आएगा इंटीग्रेशन कांस्टेंट. अगर इसको आपने c कहा हुआ है तो इसको आप c नहीं कह सकते, आप इसको मे बी c नॉट कह दें, और यहाँ पे c है. ठीक है. So you get two constants. Sum of two constant, I can write it some other constant, maybe c1. So what I get here, e raised by into e raised power -3x. These are two different constants, I accept. But the sum of two constant, arbitrary constant, is another constant, because these are two arbitrary constants. They are not fixed. If we have two arbitrary constants, sum of two arbitrary constants only in an expression, we can write them another constant c1. Here, these two constants c0 and c1 or c, they belongs to they are some real numbers. Then there's some c1, which is c0 plus c, will be another constant, which is again the real number. So I can write c0 plus c is equal to c1. So in first order differential equation, I told you that we should get a one parameter family of solution. Okay. So even if we have sum of two parameters, sum of two constants, we have to write them into a single parameter in the first order differential equation. So while solving first order differential equation, we should get a one parameter family of solution, not two. So this further can be written as y is equal to, it is in fact y, okay, c1 इसको आप उधर divide करेंगे. When you divide it there, it will be 1 over e raised power -3x, and then further we can take it in the numerator to get this c1 e raised power plus 3x, not -3x. Okay. So this one, the sign will be changed. So our solution will be what? Our solution will be In fact, y is what? Y is a dependent variable, so we can write y as a function of x. And the right hand side would be c1 times e to the power 3x. So this is your final solution of the given differential equation, which is an explicit solution. Now comes the initial condition here. What is the initial condition? Now as y of 0 is equal to 2, we have written here. It is given. What does it mean? What do we have here? This is the value of x, and this is the value of y. So you have to insert x equal to 0 and y is equal to 2 in the solution which we have found here. So what do we get here? The value of this y of x, y of 0 is what? Y of 0 is 2. So we put here 2, and on the right hand side we put x equal to 0. So we get c1 here, e to the power, you get 0 here. So e power 0 is 1. What do you get? The value of c1 is 2. So this initial condition I told you in the previous lecture as well. This initial condition help us to find this unknown parameter in the family of one parameter family of solutions. Okay, these are infinite many solutions. A particular solution which satisfy your condition, this condition of your physical phenomena, is basically your particular solution. And what will be the final solution? If C1 is 2, then the final solution is what? Then the final solution is what? It is 2 times e to the power 3x. So this is your, along with this is your final particular solution, which suits your physical phenomena which you are trying to get the solution of. I hope you get it. If you have any question, you can ask me.
सर इसको अगर सेपरेबल डिफरेंशियल इक्वेशन से सॉल्व करते हैं तो मेरा तो आंसर डिफरेंट आ रहा है. मेरा तो आ रहा है ln2 - 3.
चलें इसको दोबारा हम सेपरेबल से भी कर लेते हैं. ठीक है. We'll try to bring the same solution. ठीक है. चलें जी. इक्वेशन क्या है आपके पास? dy by dx minus 3y equal to 0. Okay. So you can dy by dx here. Sorry. dy by dx is equal to 3y. यहाँ से 1 over y dy is equal to 3 dx. लिख सकते हैं हम? Separate कर दिए मैंने variables को. So what you do here now, you apply integration. This integral 3 dx plus c. ठीक है जी. Now, after applying the integration, what do we get here on the left hand side? Natural log of y is equal to 3 times x plus a constant c. ठीक है जी. नहीं, हाँ ठीक है. Are you agree with me?
Yes, sir.
यहाँ तक ठीक है ना? Who is this talking? Ahmed. Now, you know this property, natural log of y is equal to, अगर आपके पास x है तो कैसे लिख सकते हैं इसको? Y is equal to e raised power x. This thing will go into the power of e if we try to eliminate this log from the left hand side. So this identity, I hope you know it. It's a property of natural log or logarithm. Now by using this property, what we can write here, we can write from here y. After eliminating this log from the left hand side, I have to write the right hand side e raised power 3x plus c. ऐसे लिख लेंगे. Now this thing e raised power 3x I can write into e raised power c. Okay, I'm separated the terms here. Now e raised power c is what? QML. It's a constant. C is arbitrary constant. E power c is another arbitrary constant. So I'm going to write here, instead of e power c, I'm going to write c1 e raised power 3x. Why? What do we get here? The same solution which you obtain by using the other technique. क्यों ठीक है एहतशाम?
Okay, sir. Thank you.
Okay, you can get the same solution after applying some basic techniques of mathematics or algebra or some other technique of logarithm. You can obtain the same solution. But even if you obtain some, अगर आप यहाँ तक छोड़ देते हैं इसको, you say that this is your solution, then even then it is okay. There's no problem here. This will be your implicit kind of solution, okay? But this is your explicit solution. If some student leave it here and doesn't simplify this thing further, this is also the correct solution. No one can say that this is not your this is your incorrect solution. Okay? So it depends on the simplifications. You can get the same solution by applying two different techniques, but if you don't do further simplification, the solution could look like different by both techniques. I hope you get it. You got it now?
Yes, sir.
Disham? Okay. The solution could be different, but
Yes, sir.
after some further simplification, you can make them similar. So this was all about the linear first order differential equations. And also we can simplify, we can solve initial value problems in this way. While solving initial value problems, after solving the first order differential equation by using some appropriate technique in order to solve it, when you get the solution, then you have to apply the additional initial condition in order to find the value of that constant. Okay. I hope you get it. If you have any question, you can ask me. Otherwise, we are going to stop this lecture here today.
Sir, do we have a quiz this week?
Yes, I have sent an email to every one of you. I hope you get it. I have mentioned the syllabus as well.